Hey there, hi teacher, hi classmates. Today I'll talk about design principles of software. The software design principles are fundamental to creating maintainable, scalable, and robust systems. Among the most prominent are the solid, dry, KISS, and GNA principles, which guide developers in writing clean, modular code. This article explores this case concept, illustrating them with a practical example in Python and demonstrating their impact on software quality. The code demo or demo is in link or GitHub. Yes, is this good? Well, software design is the backbone of efficient systems engineering. It involves the creation of specifications to meet objectives using primitive components and constraints. Principles such as abstraction, modularity, and reusability allow structuring complex systems in an intuitive way. In this article, we talk about solid principle. SRP, OCP, LSP, ESP, DEP. Well, the first, single responsibility principle. The SRP states that a class should have a single responsibility, which means that there should be only one reason to modify it. Example, instead of having one class that handles both user data and authentication logic, it can be split into two classes, one for user data and one for authentication. For example, class user. The variable self name is a name and self email is a email. OCP, open closed principle. This principle indicates that classes should be open for extension but closed for modification. For example, class user repository. LSP, list substitution principle. The LSP states that subclasses must be replaceable by their basis classes without altering the behavior of the program. For example, if a base class Bird has a fly method, all its subclasses must implement it correctly. If a subclass, such as a penguin, cannot fly, then it should not inherit from Bird. ESP, Interface Segregation Principle. The ESP suggests splitting large interface into more specific interfaces to prevent classes from implementing methods they do not need. Instead of having a generic interface for a multifunction devices, separate interfaces such as printer and scanner can be created, allowing classes to implement only what is necessary. Dependency inversion principle. DEP states that classes should depend on abstractions instead of dependency directly on concrete implementations. Example, in a notification system, you can create a notifier interface and have concrete classes such as email notifier or SMS notifier implement that interface. In this way, the main service depends on the interface and not of specific classes. In conclusion, applying design principles such as solid transforms software development, reducing errors, and facilitating maintenance. The Python example is demonstrates how dependency inversion and modularity enable flexible systems to be built. In a world where change is constant, these principles are not optional. They are essential to developing quality software. The code demo or demo is in this link GitHub, and that's it's all. Thank you.